A quick review of some geometry that you may have done in previous years regarding similar figures and scale factors. We're going to focus completely on triangles this time. So what are similar triangles? Well, here you have pictured two triangles, triangle ABC and triangle DEF. Triangle ABC is similar to triangle DEF if the corresponding angles are congruent and the ratios of the corresponding sides are equal. So that means that if I look at this angle, CAB, or angle A for short, and I compare it to the corresponding angle of the other triangle, EDF, or angle D for short, those two should be congruent if these are similar triangles. The same with ABC and DEF, the little peak angles, and the same with ACB and DFE, the little right angles. If those angle pairs are all congruent, now I move on to my side lengths. If I make a ratio of AB to DE, AC to DF, and BC to EF, you notice in every case I'm always putting the sides from one triangle on the top and the sides from the other triangle on the bottom. If I can make those ratios, and those ratios are the same number every time, then these two are similar triangles. It just means that triangle ABC, which visually looks larger, must be some enlargement of DEF, like when you enlarge something on a copy machine. So let's decide if these sets of triangles are similar. Pause the video and see if you can investigate whether or not the pairs of triangles are similar. Welcome back. Let's double check. Well, when I look at a triangle, I know everything in a triangle, as far as angles, adds up to 180. So 50 and 90 is 140. That means this top angle must be 40. Oh, that matches this one. That means these must be 50. So angle A and angle D are congruent. Angle B and angle E are congruent. So now I'm going to start making ratios. I'm going to compare 20 to 8, because they're both the long hypotenuse side. I'm going to compare 15 to 6, they're both the heights. And I'm going to compare 13 to 5.2, they're both the bases. When I make those three sets of ratios, I got 2.5 every time. Therefore, triangle ABC is similar to triangle DEF. The corresponding angles are congruent, and the ratios are all equal to 2.5. Let's come over to this middle set of triangles. All I had were sides to work with, so I'm going to test those first. I compared the height 10 to the height 7. I compared this base of 28 to this base of 15. And I compared this hypotenuse of 30 to this hypotenuse of 18. Well, when I look at those three ratios, those are not the same. Therefore, triangle bat and triangle sun are not similar. If I look at my last set here, and it's important, we probably are going to disregard this angle because we don't have anything in the other one to give us a clue. Let's compare again. I'm going to compare this flat side to this one, this height to this height, and then I have X and Y. Well, I compared those two and I got 3.5. If I really want to be thorough, I need to know what X and Y are so that I can compare them as well. So I use the Pythagorean theorem. A squared plus B squared equals C squared. I got X was about 30.5. I got Y was about 8.72. Comparing those two sides also got me 3.5. Since the three sets of ratios came out the same, I know that triangle dog is similar to triangle cat. So let's take a look at these two triangles. I have triangle wet is similar to triangle bog. So if the length of WE is 18, do you think you could figure out the length of BG given the information in the picture? Pause the video and try. Well, turns out that if these are similar, then I know over here from that means that 9.6 compared to 8 makes a ratio. That ratio of 1.2 is the scale factor of large compared to small. So if WE is 18, then 18 compared to BG would have to equal 1.2. That's the scale factor that exists between each pair of corresponding sides. Well, now I'm just going to solve for the BG side. Multiply by BG, divide by 1.2. So BG has to be 15. All right, now let's say that angle B is about 32 degrees. Could you figure out angle E? Pause the video. Come back when you're ready. Well, we know that angle B is congruent to angle W. That means that W is 32. We know that angle W, angle E, and angle T all have to add to 180 degrees. So 32 for W, angle E, 90 for that right angle, equals 180. Therefore, angle E was 58. So remember, corresponding angles are congruent in similar triangles, and all the angles in a triangle add to 180. So now, what is the scale factor between side WE and side ET? What if we were to look at scale factors, not similar triangle to similar triangle, but within a triangle itself? Well, okay, I'll compare. I know WE was 18, I know ET was 9.6, and so when I divide them, I got 1.875. So now do the same comparison using the other smaller triangle. Let's compare the same two corresponding sides, BG and GO. Comparing their same two sides also gets us 1.875. What does that tell us? It's actually a pretty powerful thing. If you find the ratios between any two sides of a triangle, those ratios will be the same for any similar triangle. Think about it. If this is the ratio between these two sides, now I shrink those two sides by the same factor, then shouldn't this overall fraction be the same? It's saying that these two fractions are equivalent fractions. That does make sense. This is a very important fact as we move into the study of trigonometry. If you find ratios between any two sides of a triangle, those ratios will be the same for any similar triangle. That ends our quick review of similar triangles.